Let's now move our attention to what the keyword null means and what you should imagine when there is something called null being discussed or null being referenced, right? So first off, null again kind of represents nothingness, and in case of pointers, it simply means that the pointer is pointing to the memory location 0. That's all. That's all that it means. And what the C libraries have done for us is they have defined something like so, a keyword called null, which is nothing but a void pointer, a void pointer um, considering like location 0 as a pointer, and that is what null is. So we are saying, hey, define the keyword null as 0 considered as a void pointer, meaning it's an address, and 0 is an address. That's about it. I mean, you can also keep it like so, but turns out, let's say if I were to have this and then say it's 0, this kind of gives warning, or errors, maybe not errors, but warnings. But when you do this, right, or when you do this, either one is fine, and then say, this, or simply like a decimal 0. So what it means is, hey, 0 is considered as an address, and that address we should load into P. So this syntax here that you're seeing, let me clear this. Yeah, the syntax here that you're seeing is essentially, nothing cryptic about it. It's just that the location 0, we are saying, hey, yeah, I'm telling you that this is a memory address and not just a normal number, right? That's the idea. And let's go around and play with this a little bit uh, to, become comfortable. So let me go ahead and compile the code, and something interesting will happen. All right. So what it says is, hey, on line number 3, there is a warning, and I'm redefining null, right? I'm redefining null, and it says on line 3, it is looking at a definition like so, and in the stdio.h, which we have included here, it also found on line 33 a definition, which then in turn came from stddef.h on line 395, and the definition was this. What you see here is also similar, and then recall I mentioned that you could do something like so, a decimal 0 or a hex 0. Both of them are same thing, right? Um, and so it's already defined, so we need not define it. So what I'll do then is go ahead and delete this, right, and save the file, come back and compile again. Compiles fine. Now I'm going to go and run, and what you'll notice is that it prints nil. Nil is same as, printf saying, hey, by the way, um, this address happens to be nil or 0. And let me go ahead and again print this slightly differently. Maybe LLUX, or let's try LLX. It's just a printing format. And then let me go ahead and do like a null here. So we are trying to print null twice. And let me just go ahead and put a 0x because LLX will print hex number. Long, okay, long unsigned int. So maybe, I don't know, LLUX maybe? No, LLUX. Let's see. I don't know what the formatting, or rather, I don't recall. Hmm. Um, hmm. Mhm. Expects a long unsigned int. Oh, okay. Let me then just go ahead and specify that, hey, this null, the value which you were treating like an address, oh, now go ahead and treat it like a long unsigned int. So that's what I'm doing. This operation, by the way, is called typecasting. The fact that in parenthesis, I mention a data type, that data type when applied to this value will convert this from an address to a plain number. And we don't care about it, but printf apparently cares. It tries and prints integers using this and addresses using this, and that's why we have to typecast it. But nothing special about it, just that we are getting rid of the warnings. Now I'll go ahead and run this. So you should notice that, okay, just a moment. Let's redo this. Right, you should notice that indeed this number here is 0. So yeah, that's pretty much it in terms of what null means with respect to pointers. And if there is anything that I want you to take from this video, know that null simply means that your pointer is pointing to the memory location 0x0. That's all. And that was about the null keyword. A null pointer essentially means uh, of any pointer which is having the number 0, right? So if I were to say, okay, let's do this. Let's go ahead and then say int star p equals to null, right? And yeah, so let's compile this. Compiles fine. What has happened here? What has happened here is I've taken p as a pointer, and I'm saying that it has a number 0 in it, so it's pointing to the memory location 0. Now, turns out there is usually nothing useful at the 0th location, pretty much on, uh, you know, uh, pretty much on all CPUs. Now, you have to understand that when a pointer is 0, and when we are trying to dereference a pointer that is pointing to 0, you're essentially asking for data that is stored at the address 0. And typically you don't have any data here. You might have code, like the boot code. So you have the CPU is talking to the memory, some generic buses here. And the 0th address typically has code that your CPU needs to boot up or something like that, but it doesn't have data usually. And when you're doing a star P, so to speak, where P is pointing to 0, then you're essentially trying to get data out of there, and that kind of usually is forbidden. Now I'm saying usually because it's not always forbidden, and let's explore that a little bit. You should kind of have an idea that if something points to 0 doesn't mean that the dereference will always fail. Usually the dereference fails, right? And I'll quickly go ahead and execute. This has the same output. Now what I'll try to do is I'll maybe try and print the content of star p, right? So let's go ahead and do printf followed by %d/n, and then let's go ahead and do like a star p, and then gcc. It compiled fine, but the question is, will it run? And the answer is it did not run. This crashed. So hopefully this convinces you that when trying to dereference a void, not void, but a null pointer, right? A null pointer, a pointer that is pointing to memory location 0, when you dereference it to get data, usually it fails, right? Because that location has code. Now the question is, why does it fail? And why did I say that it need not fail always? All right, so let's get rid of this. So it'll usually fail uh, on systems with OS typically, right? And when I'm saying OS, I'm saying higher level OS like Linux, like Mac, like Windows, and so on and so forth, right? On non-embedded systems, a, a null pointer dereference will fail. And the reason to that is usually between the CPU and the memory, there is some other piece of hardware, either MMU, actually MMU, which is memory management unit. And what this will do is for every process that runs on the CPU, it will ensure that it is given certain memory region whose addresses are non-zero, right? All the data, all the code that the processor has to execute will be on a non-zero location. What that means is anytime the process, the user process, so to speak, wants to go to the zeroth location, that is forbidden. The MMU will block that. The hardware will block it and send something called an interrupt or a notification back to the CPU, and the CPU says, hey, 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 you tried to reach out to the memory location 0, but all of what you required was not in the memory location 0. In fact, it was far away from that. So you should have just accessed contents within this memory limit, right? This range. So the segmentation fault that you see has to do something with memory management of the process, and the fact that no process is allowed to fetch from the 0th memory location. That is why we saw the segmentation fault. Now, in what cases is a 0th memory location access allowed? And the answer to that is when you do not have higher level OS, when you have something like a bare metal code, or if you have like an RTOS running with memory management dis disabled, right? So then what will happen is you have the CPU and you have the memory and you have the 0th location. And if there is any code here that wants to reach out to the 0th memory location, that will be all right. At least you can reach out to that memory location because no piece of hardware in between will come in your way. And also, you don't have any higher level OS running, and the OS recall also participates in memory management for the process that's running on the CPU and may block the access to the 0th memory location. So this is also something very important, which is, can a null pointer dereference always fail? Well, the answer is it will fail definitely where there is a higher level OS involved, because the OS provides like the address window or address region to the process, which is non-zero. And process has to only access addresses within that range always. And if it is going to the 0th memory location, then it's violating something. So for protection reasons, the code will fail, or you'll see segmentation fault or some bad behavior. But on a bare metal system where CPU, memory, and your code has control of entire hardware, there, 0 is a valid address. You could have things on 0th address. So hopefully with this, we have busted the myth around what a null pointer is, why segmentation faults happen, and why they're not necessary always.